Everything you think you know about the cosmos is probably wrong. From sci-fi blockbusters to common knowledge, our heads are filled with ideas about space that science has completely debunked. We are about to dismantle 30 of the most persistent space myths, one by one, using hard evidence from astronomers and physicists. By the end of this journey, your entire perspective on the universe will be reset. We will uncover why the dark side of the moon is a misnomer and how black holes are not the cosmic vacuum cleaners movies portray. Are you ready to have your reality reshaped? The very first myth we must demolish is one of the most famous. The dark side of the moon is not actually dark. This idea is a complete misunderstanding of a simple cosmic dance. Our moon is tidally locked with Earth. This means the moon takes the exact same amount of time to spin once on its own axis as it does to complete one full orbit around our planet. Think of it like walking in a circle around a friend while always keeping your face pointed towards them. You complete one full rotation yourself, but from your friend's perspective, they only ever see your front. This is precisely what the moon does. The side we never see from Earth is not shrouded in perpetual night. It is simply the far side. Over the course of a lunar month, the entire surface of the moon, near and far, gets bathed in sunlight. When we see a new moon, the far side is completely illuminated. When we see a full moon, the far side is in total darkness. The myth's persistence is a powerful testament to pop culture. It was cemented in the public imagination by the iconic Pink Floyd album, The Dark Side of the Moon. The title was poetic, not scientific, but it forever linked the phrase with the hidden part of our celestial neighbor. So, while the far side remains mysterious and unseen by earthly eyes, it experiences the same cycle of day and night as the side we know so well. Just as our perception of the moon was misled by a name, another famous claim crumbles under the harsh light of reality. The Great Wall of China is not visible from space with the naked eye. This idea feels intuitively true, a testament to human achievement so grand it should be seen from the heavens. Yet satellite imagery and the first-hand accounts of astronauts tell a very different story. From low Earth orbit, where the International Space Station flies, the wall is an incredibly challenging target to pick out. It blends into the natural colors of the landscape, a thin, weathered line often mistaken for a river, a road, or simply a shadow. Its materials, stone and earth, have very little contrast with the surrounding mountains and deserts. Think of trying to spot a single piece of gray thread from the other end of a football field. Now imagine that field is hundreds of miles across. That is the scale we are dealing with. And the idea that you could see it from the moon is pure fantasy. From that distance, 250,000 miles away, our entire planet is just a beautiful, fragile blue marble. All human constructions, every city, every monument, simply vanish. This myth powerfully illustrates a fundamental truth about our place in the cosmos. Our grandest endeavors are, on a planetary scale, incredibly small. Our perception is limited to our own human scale, but the universe operates on a dimension that is truly humbling. This idea that space itself is a gravity-free zone is perhaps the most pervasive weightless myth of all. We watch astronauts floating peacefully inside the International Space Station, and our brains jump to a simple conclusion. They are up there, beyond Earth's pull, in a perfect void of zero gravity. But that could not be further from the truth. Gravity is not something we can just leave behind. It is the fundamental force that sculpts the cosmos, the invisible glue holding planets in orbit around stars, and stars within galaxies. The Earth's gravitational field is very much present where the International Space Station flies. In fact, it is almost as strong as it is here on the surface. So why do the astronauts float? They are not floating because there is no gravity, they are falling. The station and everyone inside it are in a constant state of freefall around the Earth. Think of it like this. Imagine you are in a fast-moving elevator and the cable suddenly snaps. For those terrifying seconds before you hit the bottom, you would be weightless inside the falling box. You, the elevator, and everything else would be accelerating downward at the same rate. Now, picture the space station. It is moving sideways so incredibly fast, at nearly 5 miles per second, that as it falls toward Earth, the planet's curve falls away beneath it. It is perpetually missing the ground. This creates the continuous freefall we call orbit. The sensation of weightlessness is not caused by a lack of gravity, but by the perfect balance between the station's forward speed and the relentless pull of gravity bending its path into a circle. Scientists call this environment microgravity, a term that hints at its true nature. Gravity is there, it is just that everything is falling together, giving the beautiful and useful illusion of zero gravity. That same force of gravity, which holds the station in orbit, is responsible for a far more powerful cosmic engine. We often describe the sun as a giant ball of fire, a roaring inferno in the sky. This mental image feels right, but it is fundamentally incorrect. The sun is not on fire. Combustion, the chemical process we call burning, is a relatively tame reaction that requires 3 things: fuel, heat, and oxygen. It is the rapid combination of a material with oxygen, releasing light and heat. But the core of the sun is a place where chemistry ends and physics takes over in the most extreme way imaginable. Deep within its heart, there is no oxygen to speak of, at least not in the form needed for a fire. Instead, the sun is a colossal sphere of superheated plasma, a fourth state of matter so energetic that electrons are stripped from their atoms. Here, under the crushing weight of the sun's own immense gravity, a far more powerful process is at work: nuclear fusion. The core is a natural, continuous hydrogen bomb of incomprehensible scale. Every single second, at temperatures exceeding 15 million degrees Celsius, the immense pressure forces hydrogen nuclei to slam into one another. They do not just bounce off, they fuse, merging to create a new, heavier element, helium. In that moment of creation, a tiny bit of mass is converted directly into a staggering amount of pure energy, as defined by Einstein's famous equation. This is not a chemical release, it is a nuclear one. The energy from just 1 gram of hydrogen undergoing fusion is equivalent to burning 20 tons of coal. Now, multiply that by the billions of tons of hydrogen the sun consumes every second. That is the true source of its light and heat. Fire is a fleeting spark compared to the steady, universe-shaping power of a star. It is not a campfire in the void. It is a continuous, controlled thermonuclear explosion, held together by its own gravity, bathing our solar system in the energy that makes life itself possible. Logic would suggest the planet nearest to our star would hold the record for heat. Mercury, the swift messenger of the gods, orbits closer to the sun than any other world. Yet this seemingly obvious fact is a cosmic trap. Mercury is not the hottest planet. It endures the most brutal temperature swings in the entire solar system. During its long day, surface temperatures can soar to a scorching 800 degrees Fahrenheit. But because this tiny, rocky world lacks any meaningful atmosphere, it has no blanket to hold onto that heat. When night falls on Mercury, which lasts for weeks, all that accumulated warmth radiates unchecked back into the void of space. The temperature plummets to nearly 300 degrees below zero. A single day on Mercury carries you from an oven directly into a deep freezer. The true title for solar system's furnace belongs to the second planet from the Sun, Venus. Shrouded in thick, perpetual clouds, Venus presents a beautiful but deadly visage. Its atmosphere is almost entirely carbon dioxide, a potent greenhouse gas, and it is so incredibly dense that the surface pressure is equivalent to being nearly 3,000 feet underwater on Earth. This creates a runaway greenhouse effect of catastrophic proportions. Sunlight filters through the clouds and warms the surface, but when that heat tries to escape back into space as infrared radiation, the dense carbon dioxide atmosphere traps it with terrifying efficiency. The heat builds and builds with nowhere to go, turning the entire planet into a pressure cooker. The result is a surface temperature that remains constant at a staggering 864 degrees Fahrenheit, day and night, across the entire planet. That is hot enough to melt lead, to warp metal, and to instantly destroy any spacecraft humanity has ever sent there. So while Mercury bakes and freezes in the raw vacuum of space, Venus simmers under a permanent, smothering blanket, a stark and sobering lesson in how an atmosphere can utterly transform a world. Hollywood has painted a terrifying picture of an astronaut's suit tearing, their body instantly flash freezing into a human popsicle. This dramatic image is pure fiction. The reality of exposure to the vacuum of space is horrifying, but for reasons that defy our intuition. You would not freeze solid in an instant. The vacuum of space is, counterintuitively, an incredible insulator. Here on Earth, we lose heat in three ways: conduction by touching a cold object, convection from air or water moving over our skin, and radiation, the slow emission of infrared energy. In the empty void, there is no air for convection and no matter to touch for conduction. The only way to lose heat is through radiation, a notoriously slow and inefficient process. An unprotected human body in space would actually take hours to freeze. The immediate dangers are far more gruesome and stem from the utter lack of pressure. Your body is a vessel pressurized to match our thick atmosphere. In the vacuum, every gas-filled cavity is suddenly fighting to expand. Your eardrums would likely rupture first. The moisture on your tongue, in your eyes, and in your lungs would begin to boil, not from heat, but because the boiling point of liquids plummets when there is no external pressure holding the molecules together. This is not a hot boil, but a cold boil, a terrifying phenomenon where your own bodily fluids vaporize. The most critical threat, however, is the absence of oxygen. Within 10 to 15 seconds, the oxygen left in your bloodstream would be depleted, and your brain would shut down, leading to unconsciousness. It is a race between suffocation and your circulatory system trying and failing to cope with the vapors forming in your blood. The human body is built for a world of air and pressure, and space is the absolute antithesis of that. It is not an instant deep freeze, but a brutal, unforgiving environment that attacks our very biology in ways we are evolutionarily unprepared to handle. Our cinematic nightmares are filled with fields of tumbling space rocks, a chaotic gauntlet where pilots swerve desperately to survive. This image of the asteroid belt as a cosmic demolition derby is a thrilling lie. The reality is one of profound emptiness. Between the orbits of Mars and Jupiter lies the main asteroid belt, a region so vast and sparsely populated that calling it a belt is almost misleading. If you were to stand on the surface of one average asteroid, Your nearest rocky neighbor would typically be over 1 million kilometers away. That is a distance equivalent to traveling from the Earth to the Moon and back again twice. Navigating a ship through this region is statistically far safer than flying through the satellites orbiting our own planet. Spacecraft missions have proven this time and again. Probes like NASA Dawn did not dodge and weave through a dense obstacle course on its journey to the dwarf planet Ceres. It flew on a precisely calculated path, its cameras mostly seeing empty space, with the occasional distant, lonely rock drifting in the void. The dramatic asteroid chase in The Empire Strikes Back is spectacular cinema, but terrible science. The belt is not a crowded junkyard, but a relic of the solar system's formation, a place where countless pieces of a planet that never formed are scattered across such an immense volume that they almost never meet. A chance collision between two large asteroids is a cosmic event that might happen only once every 10 million years. The true danger is not the clutter, but the sheer, silent scale of it all. Black holes have been branded the ultimate monsters of the cosmos, ravenous beasts that suck in everything from light to entire galaxies. This terrifying reputation is a gross exaggeration. A black hole is not a cosmic vacuum cleaner roaming the void. Its gravity is no more inherently powerful than that of a star with the same mass. Imagine our own sun, the anchor of our solar system, were instantly swapped for a black hole of precisely the same mass. Cataclysmic as that sounds for our daylight, the Earth's orbit would not change in the slightest. Our planet would continue tracing the same elliptical path through the darkness, year after year, held in place by the very same gravitational grip. The danger of a black hole does not come from some supernatural sucking power, but from its unparalleled density. All that immense mass is crushed into a point of infinite density, a singularity surrounded by the event horizon, the point of no return. It is only if you venture recklessly close to this boundary that the gravitational forces become extreme. The pull on the side of your body facing the hole becomes so much stronger than the pull on your feet that you would be stretched into a long, thin strand of atoms, a process poetically and terrifyingly known as spaghettification. But from a safe distance, a black hole's gravity behaves just like the gravity of any other object. They do not hunt, they do not chase, they simply exist, and it is only our own foolishness, our venture into their final embrace, that would lead to our doom. The same gravity that sculpts black holes also pulls gently on our world, creating ocean tides and fueling a myth that has persisted for centuries. Many remain convinced that the full moon exerts a strange power over the human mind, causing spikes in crime, emergency room visits, and outright madness. This belief is so ingrained that police stations sometimes brace for a busy night and hospital staff prepare for chaos when the moon is full. Yet when scientists sift through the data, the correlation vanishes. Decades of rigorous statistical analysis, examining millions of records from police reports and hospital admissions, reveal no abnormal increase in human turmoil during the full moon. The rates of violent crime, psychiatric episodes, and traffic accidents remain consistent with any other night of the month. So why does this idea feel so undeniably true? The answer lies not in the cosmos, but within our own brains, in a mental shortcut known as confirmation bias. We are pattern-seeking creatures. On a night when the moon is bright and dramatic, we are primed to notice strange behavior. A single loud argument or a frantic call to emergency services stands out, and our brain immediately connects it to the brilliant moon in the sky. But on an ordinary, moonless Tuesday night, the exact same events occur and we dismiss them as random, never seeking a celestial cause. We remember the hits and forget the misses, weaving a story that feels right but collapses under scientific scrutiny. The moon's pull moves entire oceans, but it does not tip the scales of human sanity. Our own minds can trick us into seeing patterns in the moon, but our language can create even deeper misunderstandings about the cosmos. We call it the Big Bang, a name that conjures images of a colossal fireball detonating in a dark, empty void. This mental picture is almost entirely wrong. The Big Bang was not an explosion in space. It was the sudden, rapid expansion of space itself. Think of the entire universe, all of matter and energy, and even the fabric of spacetime, compressed into an unimaginably hot, dense point, a singularity. Then, in a fleeting moment, it began to expand everywhere at once. A helpful analogy is a loaf of raisin bread dough as it bakes. Imagine you are a tiny creature living on one of the raisins. As the dough rises, every single raisin moves away from every other raisin. No raisin is the center of the expansion. The center is simply the dough itself, everywhere. This is precisely how our universe works. Galaxies are not flying apart through space like shrapnel from a bomb. They are riding along on the fabric of space as it stretches. The space between them is literally growing. This is why we see galaxies rushing away from us in all directions, with the most distant ones receding the fastest. The evidence for this incredible idea is not just theoretical. In the 1960s, two radio astronomers accidentally discovered a faint, static hiss coming from every direction in the sky. This is the cosmic microwave background radiation, the cooled and stretched remnant of the universe's first light, released when the cosmos was just a hot, glowing fog. It is the afterglow of the Big Bang itself, a baby picture of the universe, and it fills all of space, just as the theory predicted. The Big Bang was not a localized event you could have witnessed from the outside. It happened everywhere at once, and in a very real sense, we are still inside its expanding aftermath. Our lunar myth was just the beginning of a much wider celestial misunderstanding. The very idea of a permanent dark side is a ghost that haunts our view of other worlds too. Every single planet in our solar system experiences day and night, a cycle of light and shadow painted by the sun. This cosmic ballet is governed by two simple motions: the planet's orbit around the sun, and its rotation, the spin on its own axis. As long as a world is spinning, sunlight will eventually fall on every inch of its surface. Think of a globe in a dark room with a single, brilliant light bulb at its center. Slowly turning the globe ensures that every country, every ocean, gets its moment in the light. This is precisely what happens to planets like Earth, Mars, and Jupiter. Their rotations are steady, giving them familiar day-night cycles. But what about the strange and exotic worlds, the ones that seem to defy the rules? Take Venus, for instance. It is the solar system's great oddball, spinning in the opposite direction to almost every other planet. This is called a retrograde rotation. And it spins incredibly slowly. A single day on Venus, from one sunrise to the next, lasts longer than an entire Venusian year. You could celebrate your birthday twice before the sun returned to the same point in the sky. Yet even on this topsy-turvy, sluggish world, there is no permanent dark side. Its agonizingly slow spin still ensures that, over time, the sun's rays creep across its entire scorching surface. The only way a planet could have a true, eternal dark side would be if it were tidally locked to its star, just as our moon is locked to Earth. But in our solar system, no planet has this relationship with the sun. They all dance to their own unique rhythms, each one basking in the light and resting in the dark. a universal rhythm that banishes the myth of a permanent shadow for good. The colossal achievements of space exploration create an illusion of limitless funding. We watch rockets launch and rovers traverse alien landscapes, and we assume an astronomical budget must be fueling it all. Yet the financial reality of NASA is one of the most humbling myths in all of science. The agency's budget is not a black hole for taxpayer dollars. In fact, it represents a tiny fraction of federal spending, typically amounting to less than half of 1% of the entire United States budget. To put that into a visual perspective, imagine the federal government has $100 to spend. From that stack of cash, more than $15 would go to the military. Another $15 might be allocated to health programs like Medicare. Social Security could take nearly $20, and NASA, its share would be less than 50 cents. For every $100 the government spends, less than half of one single dollar supports all of NASA missions, from maintaining the International Space Station and developing new rockets to probing the atmospheres of distant exoplanets and studying our own changing planet. This public misperception is a powerful force. It fuels arguments that money spent on space is wasted, that it should solve all our problems on Earth first. But the reality is that the entire endeavor of cosmic discovery operates on a shoestring budget of cosmic proportions. The next time you see a stunning image from the James Webb Space Telescope or watch a Perseverance rover video from Mars, remember the breathtaking ingenuity required to turn those 50 cents into a window on the universe. We have all felt the chill of winter and the heat of summer, a rhythm so dependable we build our lives around it. Yet the most common explanation for this cycle is completely wrong. It seems logical that Earth would be warmer when it is closer to the sun and colder when it is farther away. This intuitive idea is a cosmic red herring. Our planet's path around the sun is not a perfect circle, but it is very, very close to one. The difference between our closest approach, called perihelion, and our farthest point, aphelion, is only about 3 million miles. On the scale of our solar system, that is a minuscule variation. More importantly, this slight change in distance does not line up with our seasons at all. Earth is actually closest to the sun in early January, right in the heart of the northern hemisphere's winter, and we are farthest from the sun in early July, during the peak of northern summer. If distance were the main driver, the entire planet would experience summer and winter at the same time. But we know that when it is winter in New York, it is summer in Sydney. The true architect of the seasons is not our proximity to the sun, but the persistent tilt of our world. Earth spins on an axis that is tilted about 23.5 degrees from vertical. Think of it like a spinning top leaning to one side as it circles a lamp. This tilt remains pointed in the same direction in space throughout the year, as if aimed at a distant star. For half of the year, the northern hemisphere is leaning towards the sun. During this time, the sun's rays strike this part of the globe more directly. They are concentrated over a smaller area, delivering more intense energy and creating the long, warm days of summer. At the very same time, the southern hemisphere is tilted away. The same amount of sunlight is spread out over a larger, more oblique area, making it weaker and less effective at heating the ground. This is their winter. 6 months later, the situation is perfectly reversed. As Earth continues its journey, the southern hemisphere now leans sunward, basking in summer, while the north tilts away and shivers through winter. The changing distance does play a tiny role, but its effect is completely overwhelmed by the power of the tilt. It is the angle of the light, not our distance from the lamp, that truly dictates the temperature of our world. That same profound silence extends to the most dramatic cosmic events. In the vacuum of space, no one can hear you scream or a supernova explode. The roar of a starship's engines, the thunderous blast of a laser cannon, the shriek of metal tearing through a hull, these are all brilliant pieces of cinematic fiction. Sound, as we experience it, is not a cosmic traveler. It is a mechanical wave, a physical vibration that needs something to shake. On Earth, that something is our atmosphere. When you speak, your vocal cords push against air molecules, which bump into their neighbors, creating a chain reaction of collisions that eventually reaches someone's eardrum. Underwater, sound travels even faster and farther because the water molecules are packed more tightly together. But space is a near-perfect vacuum, an expanse of unimaginable emptiness where atoms are so few and far between they almost never collide. There is no air, no water, no medium to carry those vibrations. An exploding star, releasing more energy in a few seconds than our sun will in its entire 10 billion year lifetime, would tear itself apart in absolute, terrifying silence. From a safe distance, you would see a blinding flash of light. You would feel a wave of radiation, but your ears would register nothing. The same is true for our own sun. Its continuous nuclear fusion is a cacophony of unimaginable violence, but the sound waves it generates have no air to travel through. They simply cannot escape the sun's own atmosphere. If we could somehow stand on the surface of the sun, the noise would be deafening, a constant roar exceeding 200 decibels. But out here in the void, its light reaches us in just over 8 minutes, while its sound remains forever trapped. This silent reality forces us to reimagine the cosmos not as a battlefield of noise, but as a vast, silent ocean, where light is the only messenger from the abyss. The illusion of weightlessness aboard the space station is a perfect magic trick, one we have already begun to unravel. We know the astronauts are not floating because gravity is absent, but because they are in a constant, controlled state of falling. Let us pull back the curtain on this orbital ballet with a more detailed look. Picture the International Space Station soaring overhead at 17,500 miles per hour. At that incredible speed, if you threw a baseball perfectly sideways, it would travel so far before hitting the ground that it would essentially miss the Earth entirely, its path curving downward at the same rate the planet's surface curves away. The station is doing precisely that. It is perpetually falling toward Earth, but its forward velocity is so great that it keeps missing, creating a stable, circular path around the planet. Inside the station, every single object, from a floating astronaut to a drifting tool, is also in this same freefall. They are all falling together at the exact same acceleration, which is why they appear motionless relative to each other. This is the core of microgravity. It is not that gravity has vanished. It is that you cannot feel its effects when there is nothing pushing back against you. Here on Earth, the ground pushes up on your feet, and that resistance is what you interpret as weight. In orbit, there is no floor pushing up, because the floor is falling right along with you. The stunning footage we see from the ISS, of crew members tumbling through modules or water droplets forming perfect spheres, is not evidence of zero gravity. It is a breathtaking demonstration of a fundamental truth, that falling, when shared by everything around you, feels exactly like floating. The North Star holds a special place in our cultural imagination, often celebrated as the most brilliant beacon in the heavens. This common belief, however, is another celestial misdirection. Polaris, the North Star, is not even close to being the brightest star we can see. Its fame comes not from its luminosity, but from its unique and steady position in the sky. Nestled almost perfectly above Earth's North Pole, Polaris sits at a point nearly aligned with our planet's rotational axis. As Earth spins through the night, all the other stars appear to wheel in great circles across the dome of the sky, but Polaris remains motionless, a fixed point of light around which the entire northern sky pivots. For centuries, this made it an invaluable guide for travelers and navigators. Finding Polaris meant you had found true north, yet in terms of raw brightness, it is merely a respectable star of moderate intensity, ranked about the 50th brightest in the entire night sky. The true champion of stellar luminosity is Sirius, the dog star, which blazes in the constellation Canis Major. Sirius outshines Polaris by more than 25 times, casting a brilliant diamond-white light that is unmistakable in the winter sky. Other stars also far surpass our northern guide. Canopus, the second brightest star, gleams in the southern hemisphere, while Vega and Arcturus dominate their sections of the sky with a radiance that easily dwarfs the humble Polaris. If you were to look at a star map comparing their apparent magnitudes, the scale used for brightness, Sirius would be a blazing negative 1.46. Polaris would be a far dimmer 2.0, lost in a crowd of brighter, more vibrant points of light. The North Star's power was never in its fire, but in its unwavering fidelity, a constant friend in a turning sky. That same human tendency to see patterns in the stars once convinced the world that Mars was inhabited. At the turn of the 20th century, a brilliant and wealthy astronomer named Percival Lowell became utterly captivated by the red planet. Peering through his powerful, custom-built telescope in the clear skies of Flagstaff, Arizona, Lowell saw something astonishing. He meticulously mapped a complex, global network of straight, dark lines crisscrossing the Martian deserts. He called them canals, an Italian word for channels, but the English translation was unambiguous. Canals are not natural features, they are engineered. Lowell published elaborate diagrams and wrote best-selling books, arguing that these were the work of a desperate, intelligent civilization. He envisioned a dying, arid world where an ancient race had constructed a planet-wide irrigation system to channel water from the polar ice caps to their parched cities. The public was electrified. The idea of Martian engineers tapped into our deepest hopes and fears about our place in the universe, spawning a century of science fiction from H.G. Wells to Orson Welles. But Lowell's canals were a phantom, a powerful illusion born from the limits of his own technology and his own mind. His telescope, while advanced for its time, was pushing against the very boundaries of optical resolution. When you stare for hours at a faint, shimmering disk dancing in the turbulent earthly atmosphere, your brain instinctively tries to connect the dots. It links indistinct patches of dark albedo features, natural variations in the Martian soil, into straight lines and geometric shapes, a phenomenon known as pareidolia, the same quirk that lets us see faces in clouds or the man in the moon. Lowell was essentially connecting the celestial dots, sketching the lines his mind insisted should be there. The final, definitive proof arrived with our robotic emissaries. Modern orbiters like NASA Mars Reconnaissance Orbiter have mapped the entire planet with stunning, crystal clarity. Their high-resolution cameras reveal a world of vast canyons, towering volcanoes, and ancient riverbeds, but not a single straight, artificial canal. The features Lowell painstakingly charted simply do not exist. His legacy is a profound lesson in the delicate dance between observation and interpretation, a reminder that sometimes the most compelling stories we find in the cosmos are the ones we unknowingly write ourselves. Our perception of the cosmos is fundamentally limited by the speed of light itself. We confidently state the universe is 13.8 billion years old, a figure backed by solid evidence. Yet this has led to a widespread misunderstanding that the universe is only as large as the part we can see. The reality is far grander and more mysterious. The sphere of space we call the observable universe is just our local neighborhood, a bubble centered on Earth with a radius of about 46 billion light-years. This is the cosmic horizon, the absolute limit of what we can possibly detect. Beyond this boundary, galaxies exist whose light has not had enough time since the Big Bang to reach our telescopes. They are forever hidden from our view, not because they are not there, but because the universe is still too young for their messages to arrive. Think of it like standing in the center of a vast, foggy plain. You can only see a certain distance in any direction, defined by how far light can travel through the haze. But the plain itself extends far beyond your field of view. The entire universe is likely much larger than our observable bubble, and it could very well be infinite. The part we call the cosmos is just the part we have gotten the mail from. Every new observation, every photon that strikes our detectors, is a letter from the past, telling the story of our local cosmic volume. The rest of existence remains a magnificent, unread book. That lunar perspective we just explored reveals an even more stubborn myth about what the human eye can perceive from deep space. The Great Wall of China is not visible from the moon. This idea is a powerful extension of the falsehood we tackled earlier, pushing the claim to its absolute physical limit. From the lunar surface, 250,000 miles away, the Earth hangs in the blackness as a beautiful, swirling marble of blue and white. To even suggest you could pick out a single human structure is to misunderstand the fundamental limits of human vision. The science behind this is rooted in a concept called angular resolution, which is the eye's ability to distinguish two separate points as distinct. For a person with perfect 20/20 vision, the absolute theoretical limit is about 1 arcminute, which is 1/60th of a degree. Think of the full moon in the sky. It is about 30 arcminutes across. Now, let us apply this to the Great Wall. From the moon, the wall would appear incredibly narrow. Its average width is around 20 feet, but from that staggering distance, its angular size would be a minuscule fraction of a single arcsecond, which is itself 1/60th of an arcminute. It would be far, far smaller than the smallest detail your retina could possibly register. To put it in perspective, seeing the Great Wall from the moon would be like trying to see a single human hair from 2 miles away. The task is not just difficult, it is physically impossible according to the laws of optics. The Earth itself would appear about 2 degrees wide, a magnificent orb, but the wall would be an invisible thread woven into its surface. This myth was likely born from a poetic desire to see our greatest achievements writ large upon the cosmos. But the universe operates on a scale that relentlessly defies our human-centered perspective. Our monuments, for all their grandeur, are fleeting marks on a single world, utterly invisible from the next. Perhaps the most persistent space myth of all denies one of humanity's greatest achievements. The Apollo moon landings were not an elaborate hoax filmed on a soundstage. This conspiracy theory unravels under the sheer weight of physical, verifiable evidence left on the lunar surface itself. Consider the laser-ranging retroreflector arrays, suitcase-sized panels of corner cube mirrors placed by the Apollo 11, 14, and 15 crews. These are not powered devices. They are simple, sophisticated prisms. To this day, observatories on Earth fire laser beams at these precise locations on the moon. The light travels nearly 250,000 miles, bounces off the reflectors, and returns to our telescopes. By precisely timing this round trip, scientists can measure the distance to the moon with an accuracy of a few millimeters. This ongoing experiment, conducted independently by multiple nations, would be impossible if those panels were not exactly where NASA said they left them. Then there are the rocks. The Apollo missions brought back 842 pounds of lunar material, samples that have been shared with scientists across the globe. These are not like any rocks found on Earth. They contain isotopes and mineral compositions that only form in an environment with no water, no atmosphere, and no magnetic field. They are pockmarked with tiny craters from micrometeorite impacts, a signature of the raw space environment. Crucially, these samples perfectly match those returned by Soviet Luna probes and are utterly distinct from meteorites that originated on Mars. The global scientific community has validated their authenticity for over half a century. The conspiracy would require not just NASA, but thousands of independent researchers worldwide to be part of the secret. Beyond the artifacts, we now have pictures. NASA Lunar Reconnaissance Orbiter has been circling the moon since 2009. Its powerful camera capturing stunning high-resolution images of the Apollo landing sites. We can clearly see the disturb our own atmosphere paints a beautiful lie across the sky every single day. The sun is not the warm, golden orb our eyes perceive. Its true color, as seen from the vacuum of space, is a brilliant, pure white. This white-hot reality comes from the sun emitting light across the entire visible spectrum in almost equal measure. It is the perfect combination of every color, from red and orange to yellow, green, blue, and violet, all blended together into what our brains register as white. So why does it look so different from down here? The answer lies in the air we breathe and the way sunlight interacts with it. Our atmosphere is filled with tiny molecules of nitrogen and oxygen, and these particles scatter sunlight as it passes through. But they do not scatter all colors equally. Shorter wavelengths, like blue and violet light, are scattered far more effectively than the longer wavelengths of red, orange, and yellow. This phenomenon is called Rayleigh scattering. As sunlight travels through dozens of miles of atmosphere, the blue light is bounced and redirected in all directions, painting our sky blue. By the time the direct beam of sunlight reaches your eyes, it has been stripped of a significant amount of its blue component. What remains is a warmer, richer light, dominated by yellows and reds. This is especially pronounced at sunrise and sunset, when sunlight has to travel through the thickest portion of the atmosphere, scattering away even more blue and green light, and leaving behind the spectacular fiery hues we love. The evidence is undeniable when you compare photographs. A picture of the sun taken from the International Space Station shows a stark white disk, while any photograph from Earth's surface reveals our familiar yellow star. This atmospheric filter is a constant, gentle reminder that our perception of the cosmos is always mediated, forever colored by the very world that gives us life. The fear of a phantom planet called Nibiru reveals how easily cosmic terror can eclipse scientific fact. This doomsday story claims a massive, undiscovered world is hurtling through our solar system on a direct collision course with Earth, destined to bring an apocalyptic end. Yet if such a colossal object were real, its presence would be glaringly obvious to every telescope and gravitational model we have. A planet large enough to threaten Earth would exert a profound gravitational pull on the outer planets, subtly tugging them from their predicted orbits. We can track the positions of Neptune and Uranus with incredible precision, and their paths match our calculations perfectly, with no mysterious deviations pointing to a hidden gravitational master. The very idea of a secret planet on a long, elliptical path defies the fundamental rules of orbital mechanics. An orbit that takes it from the frigid outer dark into the inner solar system and back again would be wildly unstable over the proposed timescales of thousands of years. Such a path would either eject the planet from the solar system entirely or see it crash into the sun long before it could ever become a regular threat to Earth. The myth's origins are not in a scientific journal, but in the writings of a single author who claimed to translate ancient Sumerian texts, a claim roundly rejected by every legitimate archaeologist and linguist. This fictional narrative was later adopted and amplified by internet conspiracy theories, creating a modern legend that preys on our deep-seated fears. The silence of the sky is not a cover-up. It is the most powerful evidence we have that this phantom world is exactly that, a ghost story written in the stars, with no physical substance to back it up. Your blood would not instantly boil in the vacuum of space, but the real danger is a bizarre and terrifying phenomenon known as ebulism. We mentioned earlier that the moisture on your tongue and in your eyes would begin to boil, and this is the process at work. Ebulism is the rapid vaporization of your bodily fluids when the external pressure drops to nearly zero. Here on Earth, at sea level pressure, your body's internal fluids are held in a liquid state. The atmospheric pressure pushing down on you is strong enough to keep those water molecules from flying apart into a gas. But in the vacuum of space, that confining pressure vanishes. The boiling point of a liquid is not a fixed temperature. It is entirely dependent on the pressure surrounding it. In a vacuum, the boiling point of water and blood plummets to below your normal body temperature. This means your fluids would instantly have more than enough thermal energy to flash into vapor, even though you are not hot. However, this boiling would not happen instantaneously throughout your entire body. Your skin and your circulatory system provide a crucial layer of defense. Your skin is a remarkably tough organ, and it would offer some temporary resistance, holding your body's shape together for a short time. More importantly, your closed circulatory system is pressurized from within by your beating heart. Your blood vessels would maintain their internal pressure, preventing your blood from instantly boiling in your veins. The boiling would start at the surfaces, in the moisture-rich tissues of your mouth, nose, and eyes. You would feel the saliva on your tongue bubbling away as a cold vapor. The most critical and immediate threat, however, is the air in your lungs. The vacuum would violently pull the air from your lungs, and the water vapor lining them would immediately boil. This would rob your body of oxygen in seconds, leading to hypoxia. Your brain would shut down from lack of oxygen within 10 to 15 seconds, causing unconsciousness before most other catastrophic effects could fully register. Simultaneously, the dissolved gases in your bloodstream, primarily nitrogen, would come fizzing out of solution, much like opening a shaken soda bottle. These gas bubbles traveling through your circulatory system would cause the agonizing bends, or decompression sickness, blocking blood flow and damaging tissues. So while the chilling image of boiling blood is a graphic exaggeration, the true sequence of events is a brutal race between suffocation, ebulism at your body's surfaces, and internal gas embolisms, a horrifying combination that reveals just how perfectly tailored we are to our own world's gentle, life-giving pressure. Our own moon hides a secret shape right before our eyes. It looks like a perfect silver sphere hanging in the night sky, but its true form is an oblate spheroid. This means the moon is slightly squashed, bulging out around its middle like a person who had a very large lunch. The difference is tiny, only about 2.5 miles from its polar diameter to its equatorial diameter, but it is absolutely real. This subtle distortion is a direct result of the moon's rotation. Just as a spinning pizza dough stretches outwards, the moon's once molten material was pulled by centrifugal force, creating a permanent equatorial bulge. This is not a static relic either. The moon's gravity field is incredibly lumpy, a fact dramatically revealed by NASA Grail mission. Twin spacecraft named Ebb and Flow spent months meticulously mapping the moon's gravitational pull by flying in formation and measuring the tiny changes in distance between them as they flew over mountains, craters, and hidden masses. They discovered regions called mass concentrations, or maskins. These are massive, dense pockets of material lurking beneath the lunar surface, often buried within the giant, dark plains we call Maria. These maskins create a gravitational landscape of unexpected hills and valleys. If you were an astronaut walking with a gravimeter, your readings would jump and dip as you traverse the surface, pulled more strongly in some places than others. This uneven pull is so significant that it can subtly alter the orbits of satellites circling the moon. The perfect celestial orb of poetry and song is, in scientific truth, a slightly flattened, gravitationally lumpy world, a testament to its violent history and the dynamic forces that shaped it. The human brain is a master of recognition, so adept it often finds meaning in meaningless noise. This powerful psychological glitch, known as pareidolia, is the true architect of one of the most famous space myths of all time, the so-called face on Mars. In 1976, NASA Viking 1 orbiter was mapping the Martian surface when it captured an image of a particular mesa in the Cydonia region. The sun was low in the sky, casting long, dramatic shadows across the rock formation. In the grainy, low-resolution picture, a shape emerged that was startlingly humanoid, a face staring blankly up from the rusty soil. It had 2 eyes, a nose, and a mouth. The public imagination ignited. Could this be a monumental statue, a relic of a long-lost Martian civilization? The idea was irresistible, a siren song of cosmic companionship. For decades, the face became a cornerstone of alien conspiracy theories, a symbol of what NASA might be hiding. But science, armed with better technology, eventually returned for a closer look. In the late 1990s and 2000s, new orbiters like Mars Global Surveyor and Mars Reconnaissance Orbiter flew over Cydonia with vastly superior cameras. They captured the mesa in stunning high resolution, from multiple angles and under different lighting conditions. The mysterious face vanished, replaced by the truth. It was simply a large, eroded butte, a natural table mountain covered in rocks and sand. The haunting eyes were just sunken pits, the nose a central ridge, the mouth a debris-filled gully. With crisp detail and the sun high overhead, the illusion was completely shattered. There was no symmetry, no artistry, only the random, beautiful chaos of geological processes. We see faces in clouds, in the gnarled bark of a tree, and in the static of an old television. Our brains are hardwired for this, a survival mechanism that once helped us spot predators in the undergrowth. On Mars, we saw what we wanted to see, a silent sentinel waiting for us. The reality is both humbling and more profound. Mars is a world of natural wonders, sculpted by wind and time, and its greatest mysteries are written in the rocks, not in the ghosts our own minds project upon them. Our own planet plays the very same trick on us with the coming and going of the seasons. A deeply ingrained belief insists that summer arrives because the Earth snuggles closer to the sun, while winter comes when we drift away. This feels perfectly logical, yet it is a complete inversion of the truth for half the world. The real story is written in the lean of our world, not in the slight wobble of our path. Earth's orbit is not a perfect circle. It is a very subtle ellipse, so close to circular that the difference is almost negligible. But this elliptical path does exist, and it places us at two key points each year. Perihelion is our closest approach to the sun, and aphelion is our farthest point. Here is the cosmic surprise that shatters the myth. For the northern hemisphere, the Earth is actually at its closest to the sun, at perihelion, in early January. This is the heart of their winter, and we are farthest from the sun, at aphelion, in early July, the peak of their summer. If distance were the primary force behind the seasons, the entire globe would swelter in January and shiver in July. But we know that is not what happens. When New York is buried in snow, Sydney is baking on the beach. This bizarre flip proves that our distance from the solar furnace is a minor actor in the seasonal play. The true director is Earth's constant, unwavering axial tilt of about 23.5 degrees. Picture a spinning top that is permanently leaning to one side as it circles a bright lamp. This tilt means that for half of the year, the northern hemisphere is angled toward the sun, bathing it in more direct, concentrated sunlight for longer hours. This is their summer. At that same moment, the southern hemisphere is tilted away, receiving the same amount of sunlight, but spread thinly over a larger area, creating their winter. 6 months later, the situation reverses. The slight variation in distance caused by our elliptical orbit does have a tiny effect, making northern winters very slightly milder and southern summers very slightly hotter than they would be otherwise. But this influence is utterly dwarfed by the overpowering effect of the tilt. The real reason for the season is not a cosmic yo-yo effect, but a persistent, graceful lean that gives our world its rhythm of life. Hollywood would have you believe a meteor is a molten fireball, sizzling as it buries itself in the ground. The truth is far stranger. Most meteorites found on Earth are not hot. They are cold, sometimes even covered in a thin layer of frost. This paradox begins with their journey. A meteoroid, the actual piece of rock or metal, spends eons drifting in the deep freeze of space, where temperatures hover near absolute zero. When it finally plummets into our atmosphere, the air in front of it cannot get out of the way fast enough. This compresses the air molecules violently, heating them to a white-hot incandescence, and we see this glowing shockwave as the meteor streaking across the sky. The rock itself is briefly surrounded by a furnace, but it is a terribly poor conductor of heat. Think of passing your hand quickly through the flame of a candle. Your skin does not have time to absorb the heat and burn. A meteor's trip through the atmosphere is incredibly brief, often lasting only a few seconds. The intense heat simply does not have enough time to soak all the way through the rock. Only the very outer surface, perhaps a millimeter thin, melts to form a dark, glassy fusion crust, while the interior remains frozen, preserving the chill of its interstellar voyage. When it hits the ground, the encounter is not a sizzle but a thud. Hunters who recover fresh falls often report the stones are cold to the touch, a final, quiet gift from the void. This profound expansion of space itself shatters another deeply intuitive idea about the cosmos. The universe does not have a center. From our perspective on Earth, it seems every galaxy is rushing away from us, which might suggest we occupy a special central position. This is a cosmic illusion. The principle that governs the large-scale structure of the universe, the cosmological principle, states that the universe is both homogeneous and isotropic. Homogeneous means the universe has a fairly uniform distribution of matter and energy when you look at it on the grandest scales. Isotropic means it looks the same in every direction you gaze. There are no giant walls or vast, empty voids that break the pattern when you zoom out far enough. This principle leads to a startling conclusion. No location in the universe is privileged. Every observer on every galaxy, in every corner of the cosmos, would see the same thing, all the other galaxies moving away from them. A classic analogy is the surface of an expanding balloon. Glue several small paper dots onto a deflated balloon. Now slowly inflate it. As the balloon expands, each dot moves away from every other dot. From the perspective of any single dot, all the others are receding. Importantly, no dot is at the true center of the balloon's surface. The center of the expansion exists inside the balloon, in a third dimension that the dots on the two-dimensional surface cannot perceive or access. Our universe is like that surface, but in 3 dimensions. The expansion is happening within the fabric of spacetime itself, and the center of that expansion is not a place within our observable universe. It is embedded in a higher dimension, or more accurately, it is everywhere at the moment of the Big Bang. We are not being pushed away from a central point like debris from an explosion. We are all riding the stretching fabric of the cosmos together, each of us at the center of our own observable universe, and none of us at the center of everything. Even our own planet's weather harbors a myth of cosmic proportions. The old saying insists that lightning never strikes the same place twice, a comforting piece of folk wisdom that is dangerously incorrect. Here on Earth, lightning is a predictable creature of habit, and it absolutely favors the same tall targets over and over again. Our global network of lightning detection sensors provides irrefutable proof. The Empire State Building in New York City is struck by lightning an average of 25 times every single year. The CN Tower in Toronto is hit dozens of times annually. And the launch pads at the Kennedy Space Center, where we send our most complex machines in the heavens, are repeatedly blasted during Florida's notorious thunderstorms. Lightning seeks the path of least resistance to the ground, and a tall, isolated structure provides that perfect, consistent highway for its immense electrical charge. This earthly truth finds a spectacular echo on other worlds, revealing that lightning is a universal phenomenon. The roiling, multicolored clouds of Jupiter are alive with electrical storms far more powerful than anything our planet can muster. The Voyager and Galileo probes listened in on the gas giant's radio emissions, picking up the unmistakable crackle of superbolts, lightning flashes that could vaporize entire cities. And on the scorching, acid-drenched surface of Venus, despite its thick, opaque clouds, scientists have detected the brilliant flashes of lightning dancing within its hellish atmosphere. This demonstrates that the physics of electrical charge separation and discharge are not unique to our world. They are a fundamental process that can occur wherever you have turbulent atmospheres and colliding particles. The idea that lightning avoids a previous strike zone is a human fiction, a story we told ourselves to feel safer in a chaotic natural world. The universe, from the storm clouds of Earth to the alien skies of Jupiter, operates on repeatable physical laws. Lightning will strike where it must, as often as it must, indifferent to our poetic reassurances. This final myth brings our journey back to the edge of our own solar system, to the lingering ghost of a world we once called Planet X. The story begins not with fantasy, but with a genuine astronomical puzzle. In the late 19th and early 20th centuries, astronomers carefully tracking the orbits of Uranus and Neptune noticed tiny, unexplained wobbles. The gravitational math did not quite add up, suggesting the pull of an unseen, massive world lurking in the darkness beyond. This search for a perturbing planet X is what ultimately led Clyde Tombaugh to discover Pluto in 1930. For a time, it seemed the mystery was solved, but Pluto was far too small to cause the gravitational tugs astronomers had calculated. The search continued, and as our technology improved, we realized the initial wobbles were measurement errors. The planet X that inspired Pluto's discovery was a phantom, yet the outer solar system is far from empty. We now know of a vast, disc-shaped cloud of icy bodies called the Kuiper Belt, and beyond it, a spherical shell of objects known as the Oort cloud. Most of these trans-Neptunian objects are small, no larger than asteroids or comets, but a few have extremely odd, clustered orbits that are tilted and stretched in similar ways. This strange alignment has led some scientists to propose a new hypothesis, not of a classic planet X, but of a possible planet 9. This would be a true super-Earth or mini-Neptune, 5 to 10 times the mass of our world, on a gigantic, elliptical orbit thousands of times farther from the Sun than Earth. Its immense gravity could be shepherding these distant objects into their peculiar paths. The key word here is hypothesis. Planet 9 is a compelling mathematical possibility, a potential explanation for an orbital mystery, but it has not been directly observed. Our most powerful telescopes are still scanning the depths, searching for a faint pinprick of reflected sunlight. The popular image of a malevolent Nibiru or a confirmed 10th planet is pure fiction. The reality is a frontier of ice and rock, where the slow dance of distant orbits may yet reveal one last giant world, not as an apocalyptic threat, but as a final, majestic piece of our solar system's puzzle. Reality is a moving target, reshaped by every new discovery. We have journeyed through 30 cosmic misconceptions, from the moon's so-called dark side to the silent vacuum that defies our cinematic nightmares. Each myth, once accepted as common knowledge, has been dismantled by the relentless engine of scientific inquiry. This process is not a sign that we were foolish, but a testament to our growth. Our understanding of the universe is not a static monument, but a living, breathing conversation, constantly revised by new evidence and deeper questions. The true wonder lies not in clinging to comfortable ideas, but in having the courage to let them go when the data tells a different story. Let this be your call to look at the night sky with fresh eyes. Question the assumptions you hear, seek out the evidence behind the headlines, and embrace the beautiful, humbling truth that there is always more to learn. The cosmos is far stranger and more magnificent than any myth we could invent. If this journey reshaped your perspective, share it with a fellow explorer. Your likes and subscriptions help us continue unraveling the universe's greatest mysteries, one debunked myth at a time. And we want to hear from you. What is the most surprising space fact you have ever learned, or the wildest myth you once believed? Drop your thoughts in the comments below, and let's keep the conversation soaring.